Assalamualaikum and good day everyone. We are from group 4 and now we will be showing our results for other example number 1. So this is the table that have been given to us, where we can see that we have 3 hot streams and 3 cold stream, and how we look at our stream is if the temperature target is lower than temperature supplied, so it is the hot stream. Meanwhile, if the temperature target is higher than the temperature supplied, so it is a cold stream. So from this data we have to do three steps to calculate our result, which is the first one is the hot and cold composite curve, the second one is problem table algorithm, and the third one is the grand composite curve. And we also been given a difference of change in T mean, which one of us have to do one change in T mean, which 10 degrees Celsius, 20 until 40 degrees Celsius. Okay, so the first step that we have to do is to calculate our CP by using this formula, and here we get our CP, and from this CP we will do the next step, which will be explained later by my colleagues.
Okay, as desired by the question, basically it wants us to solve to find out what is the hot and cold utilities by using 3 methods, which are either by using hot and cold composite curve, problem table algorithm, or grand composite curve. So first and foremost, I will explain how to find the hot and cold utilities by the means of hot and cold composite curve. So we first plot the hot composite curve from the data that we got in the question. Basically, we got 3 hot streams from 180 to 80 degrees Celsius, 280 to 120, and 140 to 40. So from these 3 lines, we are trying to merge it into one hot composite curve. So how we are going to do this is basically by from the difference in temperature that we got, we multiply the summation of CP, and then we will got the delta H. So as we can see here, for the first overlapping of two lines, we got 2400 for the delta H. So basically, after plotting the combined 2 line, we also will be doing the same for other overlapping lines. So the final hot composite curve that we get is this shape. Okay, the same goes for cold composite curve. We also have 3 streams of cold stream composite curve, and after doing the same method with the hot composite curve, we are getting this line as our final cold composite curve. Therefore, now we are combining hot and cold composite curve into one graph. But first and foremost, we do the hot composite curve first, which is this one, and then in order to get the delta T mean of 30, we need to shift our cold composite curve into few positions. After few trial and error, this is our final cold composite curve with the delta T mean of 30 degrees Celsius, and the distance bottom here will be our QC, which is cold composite curve, cold utilities, and this one, the non-overlapping side of the hot and cold composite curve, will be our QH, which is the hot utilities, which we get around 1400.
Another method that we can use would be the problem table algorithm. Okay, for this example, our theta T mean is 30 degrees Celsius. Okay, the first step for problem table algorithm, we need to find the new temperature that has been adjusted based on this equation. Okay, for the hot stream, the temperature will need to be minus by theta T mean divided by 2, and for the cold stream, T will be added by theta T mean divided by 2. And after we have we have get the new temperature that has been adjusted. We need to rearrange the temperature from the highest to the lowest, and from that we need to find the new temperature difference, new CP and new theta H. And after that we need to perform two cascade. The first cascade will be the infeasible cascade. From infeasible cascade, the highest negative value would be our hot utilities value. And from that, we need to perform the feasible cascade. And from feasible cascade, we will be getting our pinch point and also our cool utilities. For this example, our hot utilities is 3287.5 kilowatt, and for cool utilities is 1662.5 kilowatt, and our pinch point is 215 degrees Celsius.
So from the problem table algorithm, we have already been doing the feasible cascade. So from that, we can actually continue or strengthen our value to calculate the hot utilities and cold utilities. So from the cascade, from the feasible cascade, we actually can produce the grand composite curve. So from this, we can see that we plot the 3287 to the grand composite curve at 265 and followed by the others value. And from this feasible cascade, we can actually produce the final grand composite curve. So from this final grand composite curve, we actually can analyze what is the hot utility, the cold utility, and what is basically heat that we can recover in this system. So that's all. Thank you.